It's Mr. Reeve here. We're on the third tutorial of the Knightrider series, and in the first tutorial we just talked about how to improve our Knightrider code to use for loops, and we reduced the codes a lot. In the second tutorial I just showed you how to kind of speed up the lights until it reaches a certain point and then it stops speeding up. In this third tutorial I'm going to show you how to add a button. I had a few students ask, how can we add a button that when you push the button it'll just stop the Knightrider sequence, and then when you push it again it'll start the sequence up again. So that's what I've done. It turned out it was a little trickier than I thought, and I'm going to show you the code and explain the code in this tutorial right now. First off, let's just talk about a button. So when we do button input, I'm using just a standard button, and I always connect the input to one corner, so the input's going to pin number 2 on the Arduino, and then I always use the kitty corner to be what I want when you push down the button. In this case it's going to be high, and I'm using a pull down resistor, value of 10,000 ohms, 10k, and what that does is when this button is not being pressed, then this is an open circuit, and when we read the value from pin number 2, it will come through the resistor to ground, so we will read a low. As soon as I push the button down, then the path of least resistance will go to the 5, and if I do a button read at the point when the button's pushed down, and I do a read pin number 2, then I will then read a high. Now at that point when the button's pushed down, there still is some current trickling through the resistor, but that doesn't really have an effect on the circuit. So that's how you wire up a pull down resistor in this case. There's different kind of configurations, but they all do exactly the same thing as that. Okay, so let's just take a look at the code right now, because there's something we have to change. There's one fundamental thing that we have to change when we're using buttons. Okay, so the code that we had, I've kind of added some code here, and I'm just going to explain it instead of add it with you because it's kind of complicated. But in the old Knightrider code, this was essentially the loop that we had, and we had a delay in here. The problem with using the delay and buttons is that while the processor is running a delay, then it's literally just pausing the whole processor, and you can push the button as many times as you want when it's doing that delay, and it won't recognize that the button's been pressed. So there's a good example in the Arduino examples called button no delay, or blink no delay, sorry. And that kind of shows you how to blink it without using a delay. That's good, that's a good start, and that's kind of what we have to do here as well, because what I want to do is I want to do the same Knightrider sequence, but I don't want to use the delay command. What we do instead is we just spin a loop for a certain number of milliseconds. But the good thing about doing that is we can actually read the value while we're spinning that loop of the button at any point. Okay, so we need to get rid of this delay. Now I've made a new, actually pretty much all the code that I've added is in this new method called read button. So we are going to replace the delay with read button. So we're going to replace the delay with read button and read button, and there was only delay in those two. We still pass in the speed, and remember what the speed was. The speed started at 500 milliseconds, and then it gets quicker until it reaches its limit of 100 milliseconds. So we still pass that in because we kind of still need to delay that much time. The only difference is, like I said before, we're going to be able to read the buttons as we do that delay. Okay, so let me just show you what this looks like before we continue. Then you'll have an idea of kind of what we're going to code. So run simulation. Okay, so we have our basic Knightrider. Starts pretty slow. When I push the button, it pauses. It leaves the current light on. When I push the button again, it'll just continue its sequence. Yeah, so I had lots of problems getting this running. In the end, I finally got it running to my satisfaction, and made the code kind of complicated though. The what I had to do to get it working. So we can pause it, we resume. I guess some of the problems I was running into before was when you push down the button, it'll pause it, but it does multiple reads, so right away it'll just, read and resume. So it'll pause it and resume without you even noticing it. Other problems I had was it got confused because when I pushed it down, it would stop it, and then I push it again and it would stop it and start it, or so it seems to work fairly well now, though. Okay, so let's have a look at the code. Okay, so all of the code is in this read button method that I wrote, and we pass in the delay that we want. First, let's just talk about how we can delay without using the delay command, and that's pretty much what this loop does here. So what we need to do this is a very common technique. There's a command called millis, and what that gives you is it gives you the current number of milliseconds since the program started running. Now this can get quite large, and that's why we need to declare these as a long. So they're up here at the top, both current mills and previous mills. Just set it to 0 just to initialize them, but they're long values. Long values, if you don't use longs, if you use ints, your program will crash. I remember having this happen before because those values in millis get too big for an int and the program will just crash. So they must be longs. So what we do when we first come into the read button is we read the number of milliseconds. Think of that as like a clock. The clock just keeps going up. So where is the clock when we start? And then the previous mills is kind of a reference point to when we started this method. Then we just keep repeating this code. This is the main guts of it here. Remember, the current mills is just going to keep being the current clock. We get it at the end of the loop. That's going to keep going up. Previous mills, it never changes since we set it when we entered the method. So what happens here is this one stays fixed, let's say at 500, and the current mills keeps going up. So 500, maybe it's 505, 509, 513, and you take the bigger one and you subtract the reference point when you started. And if you do that, you keep getting a difference, and the difference keeps growing. So first it was 5, then maybe 9, right? Then it was 13, and 18, and 20, and that just keeps growing as time passes. And you say, okay, well, keep spinning this loop as long as that difference is less than the delay. Now remember, that delay can be, it's milliseconds. So when we first start, the Knightrider sequence, it's 500. So keep spinning this as long as this delay between the current clock time and when we started the method is less than 500. That's what that's saying. Okay, so, but the good thing about this is we can execute code while we're waiting for time to pass. And so let's take a look at what we execute here. I do have a button set up, so if we go right up to the top, I did make a constant for the button, so it's on pin number 2, and I just added, oops, I have it twice, so that's not needed. Only one of those is needed, and it's going to be needed at the top. What just happened there? Sorry, we do need to say that pin mode is going to be input, though. Apparently I never did that. So let me just add that right now. Code seems to work pretty good. So pin mode, button pin, it will be input. Okay. So yeah, we do have button 2, or pin number 2 is going to be an input, and then we have all the other pins as being outputs. And now that lets us do a read. And so I just have a variable here. It's just a Boolean variable. Boolean variables are like any other variable, but they can only store true or false. That can also just be 0 or 1, or it can be a high or a low as well. So you'll see when I use input, we can compare that against true or false. True is also high and false is also low. Okay, so we read the input of the button. Now, typically, if the button's not being pushed, we'll get a low. So you have to remember that. So if the button input is high, that means we're pushing it down. And what we do is we just set a flag. When the flag's declared here, set as false. So we set a flag saying, hey, we pushed the button. Okay, so from this point on, that flag can never be set back to false. So as soon as we push the button, the flag is set, and it will always be true from then on. So we know that the button was pushed at some point. Okay, so that's good. That'll be good for us later. Now, we also want to know, though, if the button has been released. Because if we just hold down the button, then we need to know if we're still holding down the button or if it's been pushed up. That was one of the kind of problems that I had if you held down the button. The code didn't really behave very well. So what I do here is we say, okay, has the button been down, right? That means has this flag, have we pushed it down at some point? And is the input now low? So at some point we pushed it down, it was high, we set our flag. At some later point, yes, we've pushed the button down, but when we did this read again, because we're constantly spinning this loop, it was low, so the button's now let up. And if that's true, then we set another flag called button back up. So between the two of these, button down was we pushed the button down, and button back up means we've let it back up. So if that's the case, then both those flags will be set to true when we finish this loop, meaning that we've delayed the proper amount of time. So now let's see what we want to do. What we need to do at this point, we need to stall the code. And the way that I've done this is I'm just going to spin a loop until we push the button again. So I'm not even going to go back out to the Knightrider sequence. I'm just going to literally get into a while loop until we've pushed and released the button again. So now the code says, well, was the button pushed down? Yes. Okay, then running is false. So running's this flag, are we supposed to be running or not? And so this just says, we want to stop running because we pushed down the button. Now we might not have released it yet. We'll know that by looking at the button back up. But at this point we just say stop running. Okay, so first loop. What the first loop will do is it makes sure that we've let the button up. So this loop waits until, so for example, if we've pushed the button down but we're holding it down, then this loop will sit there and just spin until we let the button up. What it says is, while running is false, so we've pushed the button down, and also push the button back up is false, meaning we haven't let the button go. All we do is we read the input, and if it's low, then that means that we have let the button back up, and we can set this button up flag to true. Okay, so there's two ways this button, at 2 points, I guess, the button back up could be true. One, when in the delay sequence, it could be pushed down and then let up, which is probably the most typical. But in the case where either the timing or we're holding the button down, then this code would not have executed. So we would have triggered the button down, but the button back up is still false. Then all of this code is, and this code will just keep going forever if we're holding the button down. And all this code is going to do is just wait until we let that button up. Okay, so at this point, so when we are right here, then we know that there's only two scenarios that we're getting right here. Either they didn't touch the button, we delayed, we spun our loop, we delayed, and continue in the Knightrider sequence. That's scenario one. Fine. The second scenario, we push the button and then we've let it back up. We either let it up here or we let it up here. That's fine. But what we do know is if we did push the button, let's look at that scenario because that's kind of more interesting. If we did push the button, then we know that we've pushed it down and we've let it back up. Okay, so now what are we going to do? Well, now essentially we're going to spin another loop, just waiting for that button to go down and back up again. Okay, so there's a little bit of a trick involved here as well. So what we need to do is we need to figure out what is the last, or we have this variable here, the last input. So the last input was low because remember we just let the button up. Okay, so and what we need to do here is we need to know when the button goes high and then back to low. because if we just had it looking for high again, then it caused some problems, because we would push it, let it up, and then we push it and it would start going again, but then it would go back into the delay and it would still be pushed, and it kind of got confused. So I made the decision that in order for it to start, the Knightrider sequence to start up again, we have to push it and then let the button go the second time in order for it to start. So you can't just hold it down and it starts. Okay, so we assume the last input is low, and then it says, well, running is false, because remember we set that running to false because the button was pushed down. Okay, so while running is false. Now the only way that we can get out of this loop is by setting running to true. So at some point when the button goes down and then back up, we're going to set running to true again. So let's take a look. We read from the button, and if the button is high, then we say last input is high. Okay, so we just recorded that, okay, the button has been pushed at some point in this loop. Okay, so then we come back around. Let's just say running's still false, nothing's changed there. And if we're still holding the button, then button's still high, last input's still high. Okay, then let's say we let the button go here. So we read, and the input's low. Okay, is the button high? No. Is it? Is the input low? Yes. And was the last input high? Well, yes it was, because I just let up the button. In which case, set running to true. We break out of this loop, and we continue the Knightrider sequence. Okay, so that's the reason that we needed this last input is so that we knew that it went low, high, and then back to low. See, at this point, if the input was low, because we just let the button back up, running is false. But if we read low, and it says is input low, yes it is, then we set low running to true. Well, that means we just pushed it once, and the button stopped, and then it restarted again. And I had this issue, and the button was pretty much pointless. So what this last input does is it forces it to go to high before we come back and look at it to see if it's low again. So all in all, a fair amount of code, a little bit of thinking involved there to get that working. But kind of a lot of these techniques are used in a lot of programs with buttons. And let's just see it run again. I lost my Arduino. Okay, so here we go, and start. And now we have a bit better understanding. As soon as I push it down, I'm holding it down, it stops. I let it go. Okay, so it's still stopped. It's spinning that loop, waiting for me to push it again. I can push it down, but not until I let it up does the code resume. And it actually seems to be quite effective. So what I might do right now is just scroll through the whole code in case you wanted to make it work on your own system. Okay, so there's the setup. You can pause it if you need to. There's the whole loop. And then we have our important part, which is the read button. And then the rest of read button. Okay, I hope you enjoyed the tutorial, and happy coding.